All right, so a couple of more things we need to talk about here. We did one reaction, if you remember, at 35 degrees C. Same conditions as experiment 1, same volumes as experiment 1, but the only difference is that instead of 24.5 degrees, we did it in a water bath at 35 degrees C. So let's figure out the rate constant. We're going to call that K4 for experiment 4. So rate is equal to that rate constant times, we already figured out the orders of the reaction, so this goes by roughly first order kinetics decay. This reactant goes by roughly first order kinetics decay. We know the initial rate is the concentration of thiosulfate divided by 2 times delta T. That was given to us in our lab handout. Delta T here, that time for the onset for reaction 4 conditions at the higher temperature was 77 degrees. So doing that on our calculator, we can say instead of rate 4, we'll just say 35 degrees. It's about 1.18 times 10 to the minus 5 big M over seconds. So that is our rate here. And let's figure out K4. Let's plug our numbers in here. Okay, we know the protocol tells us it's the same concentrations as experiment 1. Same concentrations as experiment 1. So here we have 1.18 times 10 to the minus 5 M over second equals K4. That's what we're trying to solve for. Big M to the power of 1.03 and I minus is 0.0363 to the power of 1.12. So let's solve for K4 here. So 1.18 times 10 to the minus 5 M over seconds. Okay, we're going to move this chunk of math down to the denominator. 0.0363 M, 1.03 times 0.0363 M times 1.12. And let's do this in our calculator and get the rate constant for this higher temperature. Remember, rate constant, lowercase k, is quoted at a specific temperature. So 0.0363 to the power of 1.03, that number times parentheses 0.0363 to the power of 1.12, close the parentheses. That's the value. We're going to divide it by 1.18 times 10 to the minus 5 and then flip it. So let me put my parentheses here. 1.18 times 10 to the minus 5. All right, so that's divided by 10, this number, but we're going to really want to do the flipping of that. So that flips it. It just saves some time here. So we got K4 here is 0.0147, and the units are M to the minus 1 and seconds to the minus 1. So that is our value of K4. So that kind of makes sense here, K4 being at 35 degrees C. So this kind of makes sense to us here. At 25 or 24 or so degrees C, we have this average rate constant. Higher temperature, we would expect the reaction to go faster because of more collisions, the molecules having more molecular motion. So the rate should go higher, faster, and the rate constant, which sort of is a measure of how fast the reaction goes, is higher. Okay, so this is the rate constant at 35 degrees C.